Hello, this is Kuntal Chakraborty, Assistant Professor of Electrical Engineering Department, Greater Kolkata College of Engineering and Management, JIS Group. I'm just going to give a lecture on an important topic, that is 8051 microcontroller architecture. So, this is the 8051 microcontroller architecture block diagram, where we have CPU, in which we have the ALU. This is basically the heart of this system, and ALU basically perform different types of arithmetic and logical functions. And we have the oscillator that is connected with the microcontroller that will provide the system frequency. Generally, a crystal oscillator is used here to provide 4 to 30 megahertz frequency to the 8051 microcontroller. Next, we have 4 ports, parallel ports, that is connected with the 8051 microcontroller, and that is P0, P1, P2 and P3, by which different input output peripheral devices may be connected through this port. Means these ports can be used as input as well as output, and these ports that can also be used for the addressing, and that can be used as address bus as well as data bus. And it has a serial port by which the serial communication that can be made, and we have 2 signals, TXT and RXT, for transmission and receiving the data. It has a bus control that is associated with this system, and it has a on-chip ROM, and where we can store some program or data that is connected with the CPU through the internal system bus. Here we have a on-chip RAM, that is a 128 byte of RAM we have in 8051 microcontroller, that is also connected with the CPU through the internal system bus. And it has 2 timer 0 and timer 1, by which we can perform different types of timer and counter operations. In 8051 microcontroller has 5 interrupts. So here we have the interrupt control section that is connected with the CPU, and by using INT0 and INT1 we can interrupt, means peripheral may interrupt 8051 microcontroller. Whenever is microcontroller 8051 is operating on instructions, at that time if some peripheral device can interrupt 8051 microcontroller, then 8051 microcontroller give the access, and then the interrupt procedure that can be made. So this is the overall architecture of 8051 microcontroller, and all the part that I will discuss elaborately in the next slides. First is the ALU, that is the arithmetic and logical unit, by which we can perform different arithmetic and logical functions. Arithmetic functions like addition, subtraction, multiplication, division, that can be made by using ALU, and different functions, logical functions like OR, XOR, AND, that kind of functions that can be performed by using ALU also. So ALU is a very important part of 8051 microcontroller. Next is a accumulator, that is a 8-bit register. This register is bit addressable. By using this register we can perform different arithmetic operations of 8051 microcontroller. And we have B registers. This register is used in only 2 instructions, that is MUL AB and DIV AB. This is also a bit addressable register, and this is also a 8-bit register. So this is the registers that we have in 8051 microcontroller. Stack pointer register, this is 8-bit long, and here I already discussed A and B. And R0 to R7, these are the registers of the register bank of RAM. Each are 8-bit long. And here we have a DPTR, that is 16-bit long, and the program counter, it is also a 16-bit long. Next is the program counter. This is basically points to the address of the next instruction that is to be fetched by the microcontroller. Means this program counter basically actually maintain the sequence of the program. So by using this program counter, that is we can maintain the sequence of the program. So this program counter actually holds the address of the next byte that to be fetched by the microcontroller. And next is a stack pointer, which is 8-bit registers. The RAM location basically start from 08H to 1FH of the RAM, and it basically operates into a manner that is a first in last out and last in first out manner. And this is also a 8-bit register, and whenever we want to push some data into the stack, then the stack pointer that will be incremented by 1 every time, and whenever we pop a data from the stack, at that time the stack pointer that will be decremented by 1 every time. So this is the stack register. Next is a data pointer register. It is a 16-bit register used to hold address of the external or internal RAM where data is stored or result is to be stored. It is used to store a 16-bit of data. This is basically divided into two parts. One is a DPH and another one is a DPL. DPH means the data pointer higher order and DPL means the data pointer lower order. So this is the data pointer register. Next is a PSW, that is the program status word, in which we have some flags. That is a CUI means the carry flag, AC is a auxiliary carry flag, F0 is a user defined flag, and OV, that is a overflow flag, and EX0, that is a parity flag. Here RS1, RS0 is the register bank status. And basically the carry flag, whenever any arithmetic and logical functions performed, if there is any carry generated in the system, in the result, at that time the carry flag that will be set as 1, otherwise that will be 0. And auxiliary carry, whenever any arithmetic operations made, if carry is generated from D3 to D4 bit, at that time the auxiliary carry flag that will be set as 1, otherwise 0. And if the results we are getting from any arithmetic and logical functions after the completion of the arithmetic and logical functions, if the data overflow, then the overflow flag that will be set as 1, otherwise that will be 0. And the parity flag, that is if any parity is generated, means even parity is generated in the results, so at that time the parity flag that will be set as 1, otherwise that will be set as 0. And F0, it is user defined flag, that user can use this flag. And RS1 and RS0, these two bit that is basically used for the selection of the bank of the RAM registers. In 8051 microcontroller has 4 register banks in its RAM. So this RAM can be selected, bank can be selected by using RS1 to RS0. So we have the combinations 0001, 10 and 11, by which we can select register bank 0, register bank 1, register bank 2 and register bank 3. So this is the PSW registers of 8051 microcontroller. Next, SFR, that is the special functions registers. In 8051 microcontroller has some SFRs divided into 4 groups. First is a timer counter register like TMOD, TCON register. Serial data register like SBUF, SCOM registers. Internal registers like IE, IP registers. Power control registers like PCON registers. These are the special functions registers, and that is basically the registers of the RAM. And RAM and ROM, which is very important part of 8051 microcontroller, and in 8051 microcontroller has 128 bytes of RAM. This RAM basically divided into 3 parts. Basically it has 3 distinct area. First is 32 bytes of working registers from additional 00 address 00H to 1FH, and it has a bit addressable RAM, that is a 16 byte of bit addressable RAM, and that is from 20H to 2FH, and it has a general purpose of sketchpad RAM, that is 30H to 7FH, and this is very important memory of 8051 microcontroller. And ROM, data memory and program code memory, both are in different physical memory, but both have the same addresses. In internal ROM, occupied address from 0000H to 0FFFH, and program counter addresses program codes from 000H to 0FFFH. Program addresses higher than 0FFFH that exceeds the internal ROM capacity and will cause 8051 architecture to fetch codes bytes from the external program memory. So this is the ROM where we can store the data as well as the program. So next is the oscillator that I already discussed. This is the important part, and by which we can provide the operating frequency of 8051 microcontroller. Generally 4 MHz to 30 MHz of frequency that is provided by using the crystal oscillator, and normally we use 11.0592 MHz frequency in 8051 microcontroller. And the ports, 8051 microcontroller has 4 ports, P0, P1, P2 and P3, by which input output devices may connect through these ports. So this can be used as input as well as output, and these ports can be used as address as well as data bus also. And this 8051 microcontroller has a single serial communication port, and it has 2 signals, RxD and TxD, by which transmission and receiving of signal that can be made. So this is a serial communication port. Next part is the interrupt and timer counter. So interrupts in 8051 microcontroller has 5 interrupts. So these 5 interrupts are external interrupts INT0 and INT1, timer interrupts TF0, TF1, and serial communication interrupts R1 and T1. So interrupt procedure is that whenever microprocessor is performing a program or task, at that time, if a peripheral device is try to perform any kind of task by using 8051 microcontroller, then it will send an interrupt request through these external interrupt lines, that is INT0 and INT1. And microprocessor will completed the recent task, and after that it will give the access of the peripheral device to perform this interrupt task. So this is the procedure by which the interrupts that can be made. And in 8051 microcontroller has a timer counter, 2 timer counter registers by which we can perform different types of timer and counter operations, and this timer and counter may be operated into different modes. And the interrupts to interrupts we have that their priority that can be set through some special registers by using some special registers also. And these are the different blocks or different parts of the 8051 microcontroller that I already discussed. That is a ALU and oscillator, RAM, ROM, interrupts, timer, counter, and different ports, means the parallel ports, 4 parallel ports, serial ports, and these all are actually fabricated in a single chip. Nowadays 8051 microcontroller is very much popular, and that is available mainly in the market till now, and that is very popular. And by using this kind of microcontroller, we can perform different types of tasks where this 8051 microcontroller then can be used in embedded system. Embedded system is basically nothing but the system where the system is basically perform the same tasks different times. So where we can write the program into it, and we can install this 8051 microcontroller into the system. So here the 8051 microcontroller is a very small in size, so we can install it into any kind of system. So these 8051 microcontroller that can be embedded into a system, so that the embedded system that can be made and that can be performed. So that is the architecture of 8051 microcontroller. Thank you.